Hi, I'm Davide Onestini. I'm head of design at By the End of May, a research and design practice based in Lisbon, where we explore the future of manufacturing and crafts. In a few words, we research, design and prototype new ways of producing, new ways of making things, with a very clear perspective, making cities locally productive once again. So that if one day I need a new chair or a new toaster, I can go to a local store and find one that was made exactly in my city, maybe even in my neighborhood, taking advantage of the material resources which are available here, like urban waste. In our projects, we combine digital fabrication with biomaterial design and knowledge from traditional crafts. And we do so in order to test today the solutions that might make this vision a reality in the future. This requires a lot of imagination, a lot of unlearning, and mainly a lot of questioning. Questioning the things that we normally take for granted, questioning the way we live, the way we work, the way the economy functions. This also means questioning the technologies we use and the very notion of progress and innovation. It may be uncommon, but even if we are working with the future of manufacturing, we're not obsessed by the latest high-tech devices and modern technological breakthroughs. On the contrary, we are way more inspired by what comes from the past and from the way we used to work with materials, the way we used to create timeless artworks, and the types of tools we used to rely on. This is why our practice is intrinsically rooted in low-tech solutions and in unconventional material research and product design. Instead of asking ourselves which new technology could we invent to solve a particular problem, we start by asking which current technologies have actually created the problem we are trying to solve, and what should we do to change them instead? They might seem similar questions, but if you think about it, they are very different. Questioning the way that designers, makers and artisans make things is what this masterclass is all about. During this masterclass, we're going to explore low-tech ways that you can incorporate in your process in order to lower your work's ecological footprint, as well as to make your practice more resilient and self-sufficient. With this, I hope to make you think about your profession under a different lens, questioning aspects that maybe you didn't consider until now. I'm going to explain what I mean by low-tech, and I'm going to touch on the topics of tools, materials, and energy. I will also suggest the initial steps that you might follow in case you want to start exploring alternative techniques, and in case you are interested in getting your hands dirty. Throughout the course, I will show you a wide range of case studies that I personally find inspiring from many different disciplines, and that can help you imagine what is possible to do and that might spark new ideas related to your work. And by the end of the masterclass, you will have a series of references you can use to gain further knowledge and continue your low-tech material exploration. First of all, what is low-tech? By low-tech, I essentially mean technologies, techniques and processes that are rooted in simplicity. Therefore, simple to use, simple to find, simple to fabricate, simple to maintain and to repair. Think about bicycles, think about wood-fired ovens or composting toilets. Low-tech is of course a term in contrast to high-tech and to all the innovation which characterizes the modern lifestyles typical of Western countries. The society we live in idolizes new inventions, new automations and constant progress. But if you think about many recent technologies, you will find that the majority of them have been created to solve problems caused by earlier technologies or earlier inventions. In this sense, they are not really solutions, they are just techno-fixes. What I actually find funny is that the word technology has its origins in the Greek words techne, which stands for art or craft, and logia, which means study or knowledge. Technologia therefore means study of art, craft, technique. We tend to look at past technologies as outdated and obsolete, but are they really? As you might imagine by now, not in my opinion. And the reason why I am attracted to them, and more in general to low technologies, is because of three distinctive aspects: sustainability, accessibility, and resilience. If you think about it, everything we do nowadays is dependent on fossil fuels, and in particular, all that is considered high-tech is possible only thanks to them. I will not list all the problems related to fossil fuels because I'm sure you are well aware of the majority of them. So let's just focus on the fact that they are a finite resource and we're going to run out of them at some point. And for this reason, as soon as possible, we should transition our lifestyles to exist without them. Now, while a whole bunch of high-tech innovation developed after the Industrial Revolution would not exist today without fossil fuels, most low technology comes from earlier times or is inspired by the way we used to do things before. This means that low tech is already prepared for a post-fossil fuel world. Does it mean that we have to go back to where we were 100 years ago? Of course not. But looking at past technologies, past techniques, can inform us about different ways of doing things, hopefully more in tune with the rhythm of the natural ecosystems around us. If you want to learn more about the comparison between high-tech and low-tech, especially in terms of systemic and long-term thinking, I highly recommend checking out Low Tech magazine. It's a free online publication focused on promoting low-tech solutions with eye-opening reflections on technology, energy, and environmental sustainability. Simplifying technology makes it accessible to a larger portion of society. When it is easy to build, easy to repair, easy to understand, suddenly more people can take advantage of the technology and can take part not only in the process of using it, but also in the process of shaping the technology, changing it, improving it. This means democratizing technology and democratizing all the series of tools that allow production and manufacturing, which are often concentrated in the hands of a few. Additionally, it also becomes more economically accessible, as low-tech tools and techniques can tend to involve easily available materials and common standard parts. To have a reference, you can have a look at the work developed by Slow Lab, a collective from Barcelona, which brings together the low-tech movement and the slow movement. Among the many different things they do, they host social events and workshops aimed at showing participants how to create solar dehydrators, fireless cookers, bike generators. There's also another important point that is connected to low-tech, which is resilience. The use of low technologies is strictly linked to the notions of locality and autonomy, the possibility of not having to rely on something coming from far away. The majority of the tools we use and the objects we buy nowadays come from other countries, often from the other side of the world. But we know how volatile global supply chains are in terms of materials, in terms of products, and in terms of energy. This dependence on the outside, on the big corporations which produce what we need on a daily basis, makes us vulnerable to this volatility, meaning that issues happening even far away, like natural disasters, wars, economic downturns, pandemics, end up influencing our own activities. And I may be too optimistic, but I sincerely believe that slow technologies are a good starting point to break this dependence. A good example of this mentality is Project Camp, where people from different parts of the world are coming together in a piece of land in rural Portugal to reimagine the way we live, testing first-hand solutions related to local food production, sustainable construction, and off-grid energy systems. And along the journey, they share their research online for free with anyone interested, both with open source blueprints and weekly updates in the form of YouTube videos. As you can see, low-tech is not just one thing, and it also isn't a one-size-fits-all type of solution. Mainly it's an approach that tries to tackle several issues at once, and that we can adopt in our day-to-day life as well as in our own work. To make it easier to remember all the different facets of low-tech, I like to think of the word itself with a little twist. Low TECC. Low technology, low energy, low cost and low carbon. So, how can we adopt the low-tech approach to the tools that we use in our practice as designers, makers and artisans? First, when trying to accomplish a task, whether it's making a hole in a wooden plank or modeling clay to create a vase, it's a good idea to ask ourselves if we're using the simplest way possible. Simple, which doesn't mean easy or convenient. I'm going to give you the example that I always think about. Imagine that your task is making coffee. Now you have two possibilities to complete the task, using a pod coffee machine or using a mocha. Taking a capsule and placing it inside the machine looks undoubtedly very easy and straightforward. But if you analyze the actual process inside the machine, if you analyze the amount of different materials that go into the production of the machine, if you think that when the machine breaks, it's going to be very hard for you to understand how to fix it, maybe it doesn't look that easy anymore, right? Now, what about the mocha? Mainly it's made in one material, it almost never breaks. In fact, I can still use the one from my grandparents, and I could even use it in the middle of nowhere if I manage to create a small fire. Most of the time, the easy, convenient choices we make are only possible because of the complicated systems and infrastructures that rely heavily on cheap fossil fuels. And if we want to make responsible choices, we can just ask ourselves if a tool or a technology is more convenient. We have to take in consideration everything that went into their production and the full chain of events that make them actually work. This is basically a matter of redefining the concept of convenience and efficiency. Now, onto the type of tools which are more strictly related to your job. Think about power drills, electric saws, ceramic kilns. These are the type of tools that today we take for granted. But what happens when there's a blackout or when electricity becomes too expensive? What happens when a tool breaks down and we can't afford to buy a new one? Truth is, we are stuck. We are unable to continue our work because of an increasing dependence on external systems and external factors. What I'm suggesting for you to do is to ask yourself, what is the simplest technology I can use to get the job done? Sometimes we have to go out of our comfort zone to start imagining which alternatives we have. In the past, for every power machine or electronic device, there used to be a low-tech alternative that was working thanks to human muscles, water or wind. So why not look at the past for inspiration? We may be surprised by how many things we used to do without having highly complex tech devices and electricity. As I mentioned earlier, by the end of May, we also work with biomaterials, and very often during our research we use mainstream kitchen tools. They are great for material exploration, but sometimes I realize that most of them would be as efficient or even more efficient if they weren't electric. Take the egg beater or the immersion blender that in my studio we use to create paper pulp from paper waste or to blend agar-agar in bioplastic recipes. They could do their job perfectly even without a lot of power, and you might not know because they are hard to find in stores nowadays, but all of them have their respective manual versions, made in less materials, easier to repair, and generally cheaper. You can also find ways to adapt them in order to make them more efficient, like for example in Biceps Cultivators, a low-tech energy-free kitchen project that features a food processing module that runs on muscle power. This is done thanks to a mechanical system inspired by all sewing machines that requires only a few pedal strokes to work. Basically, this mixer lets you chop, mince, knead or blend, so you can prepare food using only human energy. On Low Tech magazine, you can find a few articles that go in depth into both hand-powered machines and pedal-powered machines. Inspired by these human-powered tools, last year I designed and 3D printed my own pulp beater, mainly because I couldn't find any around me. I know what you're thinking. I'm giving a masterclass on low tech, and now I talk about digital fabrication. Well, this is something I think about quite a lot. Are tools like 3D printers high tech or low tech? There are of course different levels. It's not just black and white. Sometimes it's a matter of finding a compromise. Over the last years, apart from becoming more mainstream, 3D printers got way more accessible in terms of prices and in terms of do-it-yourself replicability. It is super easy nowadays to build your own 3D printer by sourcing components locally and by following online instructions or tutorials. This also applies to laser cut and CNC machines. You can find DIY kits, open source blueprints, modular single parts to substitute, and so on. These tools allow you to expand the possibilities of your work while not aggravating too much on your wallet, on your autonomy, and on the ecological footprint of your practice. If you are a designer, a maker, an artisan, or an artist, in your work you constantly have to deal with materials, one way or another. I don't know about you, but I tend to think about materials quite a lot, and lately about the impact they have in the world as well. When we create something, every decision we make has a real-life repercussion, and most times it is really hard to fully understand this impact, especially when we talk about greenhouse gas emissions, which is a topic that always sounds very abstract. A few months ago, I stumbled upon this chart made by the Material Council, where they visualize very clearly the relationship between materials and the carbon dioxide emissions resulting from their production. Basically, it shows how much material you can get for 1 ton of CO2. Imagine that you want to put a limit on the emissions associated with your products, for example 1 ton. Then you will get this amount of materials, either 9.8 square meters of softwood or 3.5 square meters of plywood. This chart is interesting also from another point of view. We tend to think that recycled materials are always a good choice, but it is not always the case, because recycling requires extra energy and extra resources. See in the graphic the huge difference between wood and recycled glass or recycled steel. Of course, this cannot be the only consideration. The durability of a material is equally important, and maybe a sheet of plywood, which has less embodied carbon but is less resistant, will have to be changed way more frequently than, for example, a sheet of aluminium. In addition to this, certain types of high-tech recycling risk making things worse. An example is recycled polyester coming from plastic bottles. You are taking a waste stream which theoretically can work in a tight loop. You have a bottle, you put it in the blue bin, it gets recycled into a new bottle and the loop starts over. And in the case of the recycled polyester, you are removing it from its loop because the t-shirts you are making out of it cannot go back in the same loop and very hardly will ever be recycled. So, what according to me is the best low-tech approach towards materials is using either reclaimed materials or local ones. Today it can seem okay, to import materials that are more sustainable from outside the city, but in a future where we don't have cheap, always available fuel, it may not. And for this reason, we should find what we need close to where we are. The Low-Tech Institute, tapping into this mentality, started the 10-mile building challenge with the goal of pushing builders to think more about what it will be like to construct a house in a future where fossil fuels are not available. In short, according to the challenge, a building can be identified as a 10-mile building if it is constructed of materials that come from an average of 10 miles or less from the building site, that is around 15 kilometers. There's also another initiative, a different type of challenge that has always been incredibly inspiring to me, Made Again Challenge by Space 10, Fab City and Fab Lab Barcelona. Over 5 days, they gathered makers of different disciplines in Poblenou, Barcelona. They collected waste from the neighborhood and they worked together to imagine new production systems able to give those resources a second life. You can check out their documentary online and browse through the resulting projects. Thankfully, there are more and more initiatives of this sort all around the world, but working with local or reclaimed materials is not an easy job, especially because, first of all, you need to find them. Most cities do have what they call scrapyards, places where you can go and find unused materials, tools or components laying around waiting to be transformed into something new. And there are also community platforms that map these reclaimed materials and allow designers to find them more easily. An example is Novo Novo, based in Lisbon, that created a platform where people get access to leftover materials that are waiting to be reused, mainly from nearby companies and factories. Another one is Spazio Meta in Milan, dedicated to the recovery and reuse of materials coming from temporary events like fairs, exhibitions and fashion shows. They collect the materials, do eventual cleaning and processing, and they put them on sale for the public with prices that reflect their quality and characteristics. For this reason, I recommend you to actively search for similar opportunities in your cities, and in case you can find any, you can consider starting something along the lines yourself, because activities like these ones are super needed, and I'm sure you would have a vast audience wanting to benefit from them. Apart from communities reclaiming waste and industrial byproducts, there is also another type of communities that you may find interesting for your work: the local recycling communities. I'm referring to those people who come together and approach the recycling system from a different angle, the self-sufficient one. As I mentioned earlier, mainstream recycling is a resource-intensive and high-energy process. We collect waste from a city, we send it to some sorting facilities in the outskirts, we ship big bales of paper, plastic and other materials to recycling factories, and then we ask back the recycled products. Some people are instead building a different system for recycling, one that is much more accessible, open and local. It's the case of Precious Plastic. Precious Plastic is a global initiative whose goal is to empower individuals and communities to recycle plastic locally by providing open source blueprints for machines like shredders, extruders, presses, and people started replicating these machines all over the world. And probably there is someone doing the same even in your city. You just have to go on their website and find on the map which spaces are closest to you. One of the projects we are developing by the end of May also taps in the same idea of local recycling, but focuses on paper. Similarly to precious plastic, we asked ourselves what would it mean for a neighborhood to be autonomous in the recycling of its own paper waste. With this in mind, we started developing a series of recipes, tools and machines to enable anyone anywhere to transform paper waste into valuable material for both design and construction. The concept of low-tech is strictly connected to the concept of low energy. The type of lifestyles we are living make us addicted to energy and we don't even realize it, because it's invisible to us. The problem of this invisibility is that we take energy for granted and we think that we're always going to have plenty at our disposal. These make us very good at abusing it. If we had a set amount of electricity available each day, we will become more mindful users. Like when we notice that the battery of our phone is running low and we limit usage to essential tasks. Our current energy system is basically a dying battery, and it's crucial that we utilize it wisely, avoiding what is unnecessary. This concept is linked to what Janine Benyus talks about in the book Biomimicry, innovation inspired by nature. To give you an insight, in the book the author reflects on the fact that our work should mimic successful natural ecosystems and should follow their pace of renewal. Once upon a time, when we were just relying on our muscles or on simple slow technologies, the pace at which we were extracting resources to create products, to create energy, was way more aligned to nature's pace of renewal. But then, right after the Industrial Revolution, our pace started going way faster, and as we clearly see today, nature can't keep up with our work anymore. In terms of energy, if we want to be inspired by nature, the most evident one we should try to mimic is solar energy. And I'm not referring only to photovoltaic panels. We can utilize direct solar energy without any type of panel to warm water, buildings and food, and also to recycle plastic. This is what Sunmade is doing in Portugal. Sunmade removed the use of electricity from the plastic recycling process by using only a solar concentrator that, working like a solar cooker, can melt plastic and reach up to 200 degrees Celsius. Something similar has been achieved by gel seegers, but with metal. In the project Solar Metal Smelter, the designer shows how, with a large magnifying glass, the power of the sun can be concentrated in a precise spot to heat metal that then can be casted into a sand mold. I know that it is really hard to imagine our work without electricity. I'm the first one to admit that it's not an easy transition. What is important to me, though, is to pass the message that we shouldn't depend on it for the type of tasks that can be done in other ways, at least when feasible. These projects demonstrate that even if it is hard, it is not impossible. Earlier I talked about end power tools, and indeed there's something we tend to forget when talking about energy: human power. In the past, the main source of energy has been human energy, producing food, making clothes, building cities, and we now have passed from one extreme to the other. In comparison, today human energy has disappeared from our society because we have automated nearly every single task, even the most irrelevant. Think about the amount of automatic doors we have in our cities. And it's not that human energy has disappeared because humans aren't able to generate energy anymore. We just became spoiled by the idea of using it as little as possible. But human power, when used, of course, in an ethical way, could have a great potential. Low Tech magazine and artist Mel Smets tried to demonstrate this with their project called Human Power Plant. The Human Power Plant is a prototype where people use specially designed exercise machines, like the ones that you find in a normal gym, to generate electricity off the grid in a fun and social way. Unlike solar and wind energy, human energy is constantly accessible, regardless of the season and time of the day. Again, I don't want to urge you to start exhausting yourself with manual labor, but by getting creative and reconsidering our own human power, we could really reimagine our work environments, our workshops, and our ateliers. Take, for example, another project by Gel Seegers, the Food Power Tool Grinder. It goes along the lines of the work I presented earlier about the Human Power Kitchen. In this case, the idea of the pedal is applied to a workshop grinder for knives, scissors, chisels, and so on. If you are looking for more flexibilities, you can check the open source manual on how to create a bike generator developed by Marie Verdale and Chris De Decker from Low Tech magazine. With a bike generator of this sort, you are able to produce up to 100 watts per hour, enough to charge a battery, power a lamp, power a printer, power an electric kettle, or even to solder iron. Central to the topic of energy is also the idea of decentralization. Whether it's solar, wind, geothermal, biogas, we should try as much as possible to decentralize our infrastructures and create instead a network of local energy generators, not only at a city level, but also at a neighborhood level. Think about the possibility of producing your own energy. This would reduce waste caused by long-distance transmission and would provide a greater autonomy and, again, resilience in case of power outages, in case of blackouts, in case of interruptions caused by climatic events. If you've always worked with more traditional approaches, the low-tech one can sound intimidating and quite drastic, but it's not. You just have to get into the mindset. The greatest piece of advice that I can give you is to get acquainted with the open source hardware movement. Open source hardware refers to physical products and devices whose designs are made available to the public, usually online, with material bills, blueprints, and how-to guides that allow anyone to replicate them for free. The open source hardware movement is very in line with the concept of low tech. There are communities, both online and offline, that share the instructions on how to make virtually anything. The ones that you might find more relevant for design, arts, and craftsmanship are Wikifactory, Instructables, and Low Tech Lab. These may help you in finding, for example, the blueprints on how to create low-tech tools suitable for your specific job. Sometimes even just a search on YouTube could provide you with a lot of ideas. There are many channels dedicated to teaching how to make things with your hands, with easy-to-find materials, and mostly with tiny budgets, like Brothers Make, which features many beginner tutorials on low-tech plastic recycling. If you are willing to go even further, you should check the Global Village construction set that is being developed by Open Source Ecology. It consists of the open source development of 50 different machines, the ones that, according to the project, are fundamental to build a small, sustainable and self-sufficient community, like brick press, hydraulic motor, wind turbine, baking oven, tractor, CNC machine. At the core of these platforms and initiatives, there is the notion that we will never be able to make manufacturing and production truly accountable without sharing knowledge. Otherwise, we're always starting from scratch, always having to repeat the same effort. Still about sharing, what if, apart from sharing knowledge and designs, we create systems where we can share materials and components for our products as well? This is the goal of modular construction systems like open structures. Think Lego, but open source and way better. Open structure is a modular construction model based on a shared geometrical grid that anyone can use when designing objects, pieces of furniture, electronic devices. And this way, separate parts from different objects can be reused to construct something new. How amazing would it be if the day that I don't need the 3D printer in my office anymore, I could disassemble it and use its components to build a heating gun instead, or a ceramic wheel. By working with systems like open structures, we are incentivized to think more carefully about our design choices, and it's a very good exercise that we should do more often. As we saw before, digital fabrication tools like 3D printers give us a lot of flexibilities in terms of experimentation, prototyping, and even production. This makes 3D printing a valuable tool for low-tech material exploration if you want to create molds, if you want to make joinery components, if you want to print broken pieces of a particular tool. And by the end of May, we use 3D printing almost daily, especially for the molds we use in paper recycling and in biomaterial making. But if we want to stay true as much as possible to the low-tech philosophy, we should also consider the filaments that we introduce in the printers to generate the objects we design. The most common filaments are either in plastic or in PLA, which is compostable in an industrial environments. But now we are also starting to see new types of filaments that include organic waste into the composition, like wood, hemp, or orange peels. These are great options, but I wouldn't define their process strictly as low-tech. There are anyway systems that allow you to make filament yourself, especially from waste plastic bottles. EcoDecut, for example, created a system that converts strips of plastic from water bottles into filament for 3D printing, and released online a series of tutorials on how to do it yourself. Another thing I want to push you to try out, if you've never done it before, is experimenting with biomaterials, basically in creating autonomously the material resource that you need in your practice. Today there are plenty of online recipe books that teach you how to create ceramic using eggshells or to create bioplastics using coffee grounds. Great examples are platforms like Materium and Future Material Banks. Things get even more interesting when you combine biomaterial creation with other low-tech methodologies, like for example heating water with solar kettles that don't require electricity, or blending ingredients with a pedal power mixer. On these repositories you can also find recipes to make biopastes that can be extruded in processes similar to 3D printing. And if you don't have a suitable 3D printer at hand, you can consider experimenting first with tools that might be more accessible to you, for example large syringes or hand extruders. Bioggun is a project developed by Marcus Georgiou that transforms a common screwdriver drill into a handheld extruder for biomaterials. With the blueprints that you can find on Wikifactory and with the list of materials that are needed, you can make your own and test more rapidly the recipes that might work later on a 3D printer. This is especially interesting because now there are also many easy-to-make add-ons that allow you to upgrade your printer and make it usable with biopastes and biomaterials. An example is the extruder kit by Junai that works on all standard FDM printers and is compatible with all types of clay and organic materials. And if you don't want to buy one, the studio shares the full design and assembly manuals online with an open license, so that you can go to your local makerspace and make one. To recap what we have seen during this masterclass, I started presenting the main concepts related to low technologies and their relationship to sustainability, accessibility, and resilience. I showed you how the approach can be applied to the tools we work with, to the materials that we choose to transform, and to the energy systems that we rely on. I presented a series of starting points that can guide you during your first explorations, and now I want to leave you a few more references and resources that can help your transition from a traditional way of working to a more low-tech one. As I said many times before, a big chunk of the low-tech approach is looking at the past. And we might be amazed by the amount of things humans were already doing hundreds of years ago. Even what we call now circular economy is actually nothing new. In the Middle Ages, all the linen rags were turned into paper, most metal was reforged, new buildings were made from the remains of old buildings. Thankfully, many people already did a lot of research and we can browse their findings online. It's the case of the Museum of Old Techniques in Belgium, which is an extensive collection of hand tools, technical manuals and trade catalogs that can be all browsed on their website. Also, the Low-Tech Institute has an online section called Library with regularly updated resources on energy, tools, building, mobility, all reimagined for a post-fossil fuel world. Same goes for Low-Tech Magazine, which I strongly recommend you to check as a whole. In this particular case, check all the articles under the category Low-Tech Solutions. If you are more of a visual learner and prefer the video format when it comes to exploring, a suggestion I have for you is to check out the documentary of POC21. POC21 was a 5-week innovation camp in France, hosting 100 makers, designers and engineers to develop a proof of concept of a truly sustainable society. Basically, it was an accelerator program for 12 open source hardware projects, ranging from solar energy to closed-loop water system, from human-powered cooking to transportation. The documentary is super inspiring, and on the official website you can learn more about the 12 featured projects. All the case studies I shared with you along the course have something in common, at least according to me. They push us to shift perspective on convenience, on constant productivity, on the idea that progress and technology always go hand in hand. They somehow invite us to stop idolizing those who have more and want even more, and start instead admiring those who live simply and within their means. I honestly think that this concept is key in order to prepare the world for a future without fossil fuels, where we mimic the existing natural systems that live in a stable state, in a stable relationship with their surroundings, and that only draw as much from their resources as can be regenerated each year. With this in mind, I would like you to use the articles and repositories that I mentioned as both inspiration and motivation, to look at what's around you in a different way, to spend time looking at the bigger context and the bigger systems, and to ask yourselves different sorts of questions. How is the energy I'm using being generated? How were the materials produced? What are the conditions of the people who made it happen? Which processes in my practice are not ready for a post-fossil fuel world, and what should I do to change them? I know that there are already many other things that we have to worry about when we design something, when we create something, but at the end of the day, we are responsible for what we put out into the world. And for this reason, we have to do the hard job of asking these questions and looking for answers. This is how we move things forward. This is how we make sure that our work is not part of the problem, but part of the solution.